What's up, YouTube? This is my C++ Minecraft clone, and we'll start with a summary of what happened in the previous streams, so that viewers that are new have an idea what's up. Then viewers will vote what we're going to do today, and at the end of the stream, we'll do a summary of what happened in this stream. So, and I have a few changes that I have made from here on out. We'll test them out to see how they are. But first, let's do a summary for new people. So this is my Raylib C++ clone. And we've been working on this for about 2 months. And we have clouds, we have collision. Here we can collide. Okay, let's try this again. We have collision. Sub-Alex. We have collision, we have first time culling, which doubled the FPS once we added it. We have crafting table, which we can right click. We still cannot get a result from it. We have TNT. That's cool. Oh, and from the last stream, we added the water. But let's see this TNT explode. Yeah, from last stream, we added the water. And look at how once we add the water, oh, not this. Once we add the water, look at how it prioritized to go down, and here it shoots. At some point it splits. At some point it splits. Yeah, the flower is flying because we don't update to check if below it there's nothing. But that's fine. We have particles. But yeah, from the previous stream, we added the water. And off stream, I improved it a bit where it also removes foliage. Because before it collided with foliage, but now it removes foliage. Now it removes, and look at how it interacts with the other water as well. The only issue is the mesh is not fully complete. And the other issue is the prioritization is too strong. The prioritization is too strong because in Minecraft here it should split, not only go here but go here as well. I'm prioritizing too much, and this makes the stream feel unnatural. But at least at the end it starts spreading. Once it finds a floor here. Once it finds a floor, it starts spreading. Yeah, which is pretty cool, chat. Pretty cool. We have these spaghetti caves, which we should fix at some point. We have this simple village. We have rails. We have redstone. We have lava. Lava is not fixed. Lava is not fixed to be just like the water. And imagine if we make the water and lava collide. That would be interesting. And we have chat. Hello. We have chat, and we can summon creeper. We can summon a creeper, which actually doesn't move around too much. And I accidentally spawned 1000 TNTs. I hit the wrong button. And we have like the player movement, and we have the bunny hop from the Counter-Strike games. If you know, you know. And we have animations. We have texture animations, so that makes it possible to have the fire. This block as well is animated here. This block is animated as well. We have animations, and we have texture packs. This is the bare bones texture pack. We're not blowing up the TNT. I know what happens once we blow it. We've blown it up many times. Every time it freezes the game. So let's decide what we're going to do today, chat. I have a couple of ideas. And now let chat pick. I'll let chat pick, pop out chat, and we'll be doing some things differently. It's an experiment. And yeah, chat, this is the last stream. We'll have another one in like 7 days maybe. This is the last stream, chat, in a while, so let's have fun at least today, chat. Let's have fun at least today, chat. We'll start a poll. We'll start a poll, chat. Let me maximize it. What's up, man? We'll start a poll where we will vote what we're going to do, and the time limit will be between 1 and 2 hours, and then we'll do another feature as well. That's my idea, chat. So whatever we pick now, we'll have another poll again. So here, what to do today. And so I'll put 4 options. To fix the lava, liquid physics. So to make the lava like the water and like complete the mesh to not have gaps. And we'll make the lava interact with the water. That's my idea. Interaction with water. Oh, this is too many. Yeah, well, okay, I'll leave it like this. So another option is villagers. Finish creeper. So pathfinding, explosion. And another option is, the final option is 3D Steve, chat. These are the options, chat. These are the options. And let's start a poll. Biome blending, the nether. No, chat, these are the options, chat. I want us to make actual progress, chat. I want us to make actual progress. So let's pick, chat, let's pick. So currently chat is picking what we're going to do today. And the options are to have the lava physics, which should be pretty easy because we have the water, and we'll make the lava interact with the water to make cobblestone. Villagers is so we can have NPCs in the village. To finish the creeper, we have the static mesh, but we don't have pathfinding. So we'll need to do the A* algorithm. And 3D Steve just looks cool, man. Like, it should be cool to have 3D Steve. It would be cool to have 3D Steve. But I'll let chat pick. Thank you for these jewels and stars. I don't know what these are, but I suppose it's some kind of support. Thank you, man. Appreciate it. So we need to end the poll. We have all 3 options, the same votes. If I had to pick, what would I pick, chat? If I were to pick, I would pick the lava. I would pick the lava if I were picking. But we can do 3D Steve as well. Okay, let's end it. Okay, we'll do 3D Steve. And this will be with a 1 or 2 hour time limit. This will be between 1 and 2 hours, and then we'll do another feature. There is more votes probably because people have alt accounts. Probably. But that doesn't matter. We'll have another feature as well. Who's botting the poll? Don't worry about it. So chat voted today to add 3D Steve. So let's do that, chat. Let's do that. Let's attempt to add 3D Steve, and we'll do a timer. We'll do a timer here. Timer 1 hour. Let's do 1 hour timer, chat. Okay. We're doing 1 hour timer. And hopefully, if we have good enough progress, we'll do another feature after the 1 hour. We may need to push it to 2 hours. And then we'll do another feature. Let's try. Okay, so every time after chat does a vote, we open Minecraft just for reference. And to see how Minecraft does it, which shouldn't be that difficult. Actually, we will need a block bench as well to find the 3D Steve model. Let's open Minecraft. And hopefully we can have... Okay, so this is the 3D Steve model. This is what we're going to implement, chat. I think personally that this would look very cool, chat. If we have 3D Steve model. I think this would be very cool. It would be very cool if we have 3D Steve. So chat voted to implement this. So all of the time up until now, we've played in first person. And now we should be able to play in third person. This is what we're adding. So can we find the model? Because usually we manage to find Minecraft models through Blockbench. Let's see if we are able to find the Steve model. Let's see if we're able to find it. So we should look at... Where should we look at, chat? Entity wizard? No. Yeah, here. Regular entities. Do we have Steve here, chat? Do we have Steve? These are all of the mobs we have here. We have the iron golem. We have player head. We have slime. The sniffer. We have the sniffer. People before have wanted the sniffer. We have spider. Snow golem. Bro, there's a snow golem. And a zombie, but I don't see the player model. That's a bit of a bummer. And here the baby models. These are the baby models. Custom. What's custom, chat? Legacy. What's legacy? Do we have player model here? We have... Oh, Ender Dragon is here. Yo. What else? Bro, what's this? A Vex. What's a Vex? Is that some kind of a ghost? The zombie. The trident. Oh, to use the zombie and just change the texture. Oh, player. Here is the player, chat. Here's the player. Here is the player, chat. Okay, we have the... Oh, don't. Easy, man. Easy. Easy. Yo. We have the player, chat. Can we move it a bit? This is in edit. Rotate. So can we rotate the hand? The left arm, like this. So we should be able to play with the player. Or here, rotate head. Yeah, we should be able to use the player, chat. Yeah, we should be able to do it. Okay. We should be able to do it. So let's extract it, chat. Let's extract it. We'll extract it in mobs, maybe? No. In resources, here we have mobs, and here we have the creeper. Or maybe in model. No, not in models. Yeah, let's temporarily just put it in resources. It's fine. It's fine. Chat, you can think of what feature to add, because the player, we have a limit of 1 hour. We can push it to 2 hours, and after that we'll do a second feature. So chat, think of what feature we should attempt next in this stream. We'll be doing 2 features. We'll be doing 2 features, chat. So let me think about chat. Let me think about it, chat. Let's save the model. Let's save it. So let's export it to where? Yeah, GOTF model. And this looks fine. Confirm. In resources, and yeah, let's just put it in resources. And this is GOTF. Shouldn't it be like a binary? Should it be like a binary file? Let's try to export it again. Yeah, GOTF. And here, binary. Yeah, binary. Let's try binary. Because the creeper was a binary file as well. Yeah. Okay, we have the player model saved. We have it saved. And let's now render it in game. The Steve character. Let's render it in game. So we'll go to where? On render. We'll go on render and let me think about chat. What do we want? How should this work, chat? Let's go on layers, game layer, and let's create here. Just let's save the player model here. Player model. Let's save it here. Like this. This will be the player model. And so on attach here, player model will equal, and Raylib has a functionality to automatically load models. So here we'll do load model. And here we need the file name, so resources path. And here we do player glb, probably like that. Probably like that. I don't know what's up with the line 1 part, chat. I don't know what's up with that. But I'll leave it like that. It's fine. We'll bear with it. Let me think about chat. Okay, so we're loading the player model in game. Let's now render it. And we'll render it where? Where should we render it? Yeah, the bot is wilding. Let's pick a position to render the bot. The player. It should be, yeah, here on the 0x. We can do it on 0x, and on z. Can we do 0z? 0z is too much, I think. Yeah, okay, let's do it. Yeah, let's do it near the fountain here. Let's spawn the player here. So it should be 8, 107, 25. 8, 107, and 25. That should be the position. That should be the position, chat. So what's next? What's next? What's next, chat? We need to render it with this position. Okay, let's copy it. And let's go on render. On render, and where should we draw the player? Where should we draw a chat? After we draw the terrain. Here, if is model valid, the player model. If the player model is valid, we draw model, player model. Then the position The position is 8, 107, 25. And what else? Scale is 1 and color white. Okay, that's it, chat. So we should have the player. Refactor code is for off stream. Yo, what's up, chat? What happened here? Bro, what's up with Steve, man? Are we missing textures? What did I do wrong? Maybe the overlay. Because the model has some weird overlay. Yeah. Bro, what's up with Steve, man? This is last stream for the week. Like, this is last stream, and then the next one should be in 7 days, like the end of the next week, because I'll not have access to this PC. I will not have access to this computer. So if there's a stream, it will be different than Minecraft. Chat. I cannot stream progressing on Minecraft. I'll just have my laptop with me, which cannot handle Minecraft and streaming. That's why 7 days, no stream. But after that, it should be like before. Yeah, let's fix the model, chat. I have an idea here. If you can notice, we have these overlays here. The sleeve. Let's remove this sleeve. Let's remove the jacket. Let's remove headwear. Let's remove left sleeve. Let's remove right pants, left pants. That should be it, I think. Yeah, that should be it. So let's use this player model. Export. Confirm. And we replace the player. And let's see if now it's better. Let's see if it's better. Okay. Chat, Steve, that's Steve, chat. We have Steve. Yo, we have Steve. We have Steve. Yo, let's screenshot this guy, man. Let's screenshot him. And let me change the thumbnail. Change. Let's update the thumbnail. Let's update that. I will not update the title. I'll leave the title just so people know the update. Yeah, now there isn't an outer layer. Yeah, but we have Steve, chat. We have Steve. Let's make him an entity, chat. Should we? No, bro. It should be the player entity. It should be the player entity. Should be the player entity, right? We have the summon creeper. We have the creeper, and the creeper actually collides with the world. The creeper actually collides. Steve is just the model. We're just rendering Steve. You should copy his mic. Let me think about it, chat. Yeah, now that we have Steve here, it's a lot better, man. Now it's a Minecraft clone. Now, finally. Because something was missing, chat. All of this time, we were missing the Creeper and Steve. Now that we have them, it's a lot more like Minecraft now. So what's the next step, chat? Because we have a time limit. We have 45 minutes for Steve. We have 45 minutes. So what now, chat? What's the next step? What's the next step, chat? What's the next step? Let me think about it, chat. Next step. To make Steve be the player. Because to have it like in Minecraft here. To make it like this, chat. Bro, if we make it like this, that would be so cool, chat. To make it like this, where it follows along. That would be very cool. So this is the next step, chat. We need to make Steve be the actual player. We need to make Steve be the actual player. How are we going to do that, chat? How are we going to do that? Let me think about it. We have a player class. We have a player structure, which is where is the player structure? We have here player. This is the player. We have a player which doesn't have a model. We can add a model here easily. We can add a model here. Okay, let's move the model be in the player class and we'll create a draw method. Here we'll do void draw. I think it's even an override. Yeah, I think it's even an override. Like that. Oh, this was pathfinding test. So what now? Yeah, let's copy over the model here, player model. Copy it over into the player here. Player model, sure. And what's next? Then on attach, we need this code. This code will run it where? Where is the player? Here. We'll run it in the constructor maybe to load the model here. Okay, we have the model loading. And now we need to just draw it. Just need to draw it. Yeah, this part. This part. Let's go back to the player. Here, player. So on draw here, let's draw it. And for drawing it, we'll use the player position here. We'll just use the player position. Like that, chat. And let's see what happens. I have no idea what will happen. What's the problem here? Is this for... Yeah, this is for when loading the... Okay, we're loading the model too early. We're loading it too early. Here. We are doing it in the constructor. We should do it at some other time. Where are we handling the player? Game layer? Do we have a player here? Player is here. We should make the player be share pointer. Because if it's like this, if it's on the stack, it will call its constructor automatically. Or there's an alternative. There's an alternative. We can create a different another constructor. Yeah, that's the alternative. Yeah, in the player here, player, we'll just do another constructor that takes in a position. Vector 3 position. And that's when we'll load it. And in the default constructor, we'll not do it. That's what I'm thinking. That's what I'm thinking. So here we'll do... Yeah, position will be... Yeah, we can do it here maybe. Position. No, we cannot. We'll do it here. Like this, and here. Position, like that. We'll do it like that. Chat. We'll do it like that. So what's next? Then in the game layer, on attach, we'll... when do we set the player position, chat? When do we set player? Where do we set the play? Oh, we set it here. And where is this? It's on attach. Okay, instead of setting it, we'll just do player equals player, and the position is here. The position is here. Like that. That's my idea, chat. And this should fix the problem with loading the model. This should fix it. Okay, now we need to look at ourselves. There is a chance we're currently rendering Steve. There is a chance. There is a chance, but we're not seeing it. We should move the camera. We should move the camera. Chat. We should move the camera. Because I'm not seeing Steve. Okay. Temporarily, when we're rendering Steve, we'll render him to not be the player position, but with a little bit of offset, just to be sure we are rendering him. Yeah, when we are drawing him, we'll add an offset. What should be the offset? 1 on the X. Let's just say 1 on the X, just to see we have Steve. And then we'll just move the camera. I don't see Steve. Okay, the alternative is to have a... Oh, we're not calling player draw, bro. We're not calling player draw. That's a bummer. We shouldn't have to do it manually. We may need to just add him in an entity structure and to be called automatically, but let's temporarily just call it manually on render. After we draw the terrain, right here, we do player draw. We can do that. Let's try again. Okay, yeah, this is the player, chat. We have the player here, chat. Yeah, this is the player. Chat. What do you think, chat? What do you think? What do you think, chat? Yo. Okay, let's make him be the actual player position because we added temporarily an offset. We temporarily added an offset. So let's go in the player draw and let's remove the offset temporarily. Let's remove the offset. Let's remove the offset here. This is the player. This is the player. And he's kind of colliding. Yeah, we should offset him a bit. We should change his offset. Oh, let's draw bounding box of the collision so that we can precisely place him. And then, okay, let's move the camera to be further back and let's display the collision box so that we can position the player perfectly, and let's make the player rotate where the camera is rotating. Let's do that, chat. Yeah, but we're pretty close, chat. We're pretty close. We're pretty close, chat. And how much are we on time? We have 36 minutes, chat. We have 36 minutes. F3 plus B in Minecraft for bounding box. F3 plus B. This is what we will do, chat. This is what I want. To display the bounding box and to have Steve be in the center and to have Steve rotate with the camera. Like this. Yeah, this is what, and then we'll think of the animations. Then we'll think about animations if we have time. Interesting. Yeah, this is cool. Okay, chat, let's do this. Let's do this. So what's the plan? What's the plan? Let's move the camera a bit back. Let's move the camera a bit back. No, what happens when we are in third person and move the camera? Time set day. What happens as we go up and down? We always, we have a target. We just have it. Oh yeah, the player position is the target. Yeah. The player position is the target. Or like the torso of the player. Or maybe the head. Maybe the head is the target. We'll see. We'll see. We'll see what exactly is the target. We'll see what exactly is the target. Okay. Let's do some changes. So let's find where do we interact with the player? Where do we interact with him? Yeah, here process. Yeah, here we set the camera position. Here is where we set it. We set it to be the player position, and we offset it a bit based on the collision box. And we add a target. And the target is the camera position plus the player front. Head is target, and when head reaches limit of rotation, is rotating whole model. Head is the target. So what should be the position? Because the position changes depending on like the camera position. Right now, the camera position is changing, but the target is the same. Bro is reading chat, Mr. YouTube Kinds. I'm constantly reading chat. Eye height doesn't help me, and player height doesn't help me. Yeah, I read that, and that doesn't help me. Because I want the how last stream. It's last stream, and 7 days will be another stream. In 7 days there'll be another stream. Chat. We currently want we are setting the camera. Currently, we want to set up the camera. That's what we want. Because right now, it's stuck where the Steve is. It's stuck where Steve is. We can move it just to be a further back. But then when I rotate, now we're not looking... A bit difficult. Let's give it a simpler solution. Let's offset it here. Minus on the z-axis. Let's offset it on the z-axis by 5 temporarily, the camera, and see what's up. Yeah, okay. Look at this chat. Now we're staring at Steve. And look, this is the problem, chat. Currently, look at how now we're not looking at Steve. We want the target to be Steve. Let's change the target to be Steve. Orbital camera. Oh, you're right. Orbital camera. Yeah, Raylib had stuff like that. Orbital camera. Raylib has stuff like that. We have 30 minutes. Raylib camera player controller. Yeah, there was an example for that. Yeah, here. Space, left control. Oh, this is a cool controller, chat. Yo, this is cool. But it was a different example. Raylib camera, 3D camera example. Not this, bro. What happened with the examples? There was a very good one. No, not even this one. Yeah, this example. Yeah, so now we're just flying around and third person. This is third person, chat. This is what we want. Yes. This is what we want. It's third person. Yes, this is what we want. Wait, what happened? Okay, this is what we want. So when we here, third person, here. Camera up, one, sure. Yeah, this is camera third person. Perspective orthographic, yeah, perspective. Sure. Target. Update camera mode. Third person. Think about it. Do we have update? Where do we handle the camera? Do we have update camera? Pro. No, we don't. We don't. Yeah, we don't update the camera. We don't, because here Raylib has a function update camera, and here you can give it a mode. Usually. Yeah. There was a function called update camera, like this. And here you can give it a mode. And here we have first person, third person. Yeah, third person. That's it. Third person. And depending on if it's third person or not, we have rotate around target. Rotate around target. Where is this used? Where is this used? Camera pitch. Sure. And when moving around. Camera yaw. Bro, chill guys, chill. It's only a week. It's only a week, chat. It's only a week. It's only a week, chat. Don't worry about it. It's only a week. It's only 7 days. We can manage 7 days, chat. We can manage. Yo, Jake, what's up, Jake? What's up, Jake? Let me think about it, chat. Let's. I have an idea, chat. I have an idea. So for the position of the camera, let's leave it be here, but let's change the target. Let's change the target here. The target. Let's change it to be the player position. Let's do, bro. What happened? Let's do it to be here. Target to be player position. Like that. And let's test it. Let's test it and see what's up. I'm trying to rotate the camera, which doesn't work. Sure. We'll figure it out. But we have Steve. Let's look at from the other side. So here let's add on the Z-axis. Like this, okay. How much time do we have, chat? How much time? 25 minutes. We can add more time for sure. It was just 1 hour. Let me think about it, chat. Let me think about it. Yeah, we need to use as reference update camera. Let's use as reference the Raylib code. And we're not directly using it because we have custom implementation. For the request of stairs, currently we're doing the player model, so we're not doing stairs. And about entity architecture, ECS versus object-oriented programming, like what do you mean by that? I just have entities, that's it. I don't have... I have classes. I have an entity class. Yeah, and the player inherits the entity. So yeah, I have object-oriented design, sadly. Yeah, maybe I should have components. Yeah, maybe I should do the component stuff. But I'll think about it. Okay, let's look at how they do third-person control. So, so when the mode is third-person, move in world plane, this is true. This is true. And this is true as well. Rotate around target. And lock view, camera free, first person, third person, and this is also true. This is also true. Okay, nice, nice. And where do we use them? Well, we have just a few key bindings. We have few key bindings for moving forward, back, left and right, and to move the camera and moving the camera, like the mouse support. So let's just focus on the camera rotations. Let's just focus on that. Handling the camera moving. Gamepad movement, we don't care about this. Camera free? No, camera is not free. Camera is not free. If mode third person, yes. Zoom, target, we don't care about the zoom. Yeah, we don't care about zooming. We don't care about zooming. And keyboard support, yes, we need this. And here, what's this? Mouse delta. This is for camera free and the middle mouse button. Oh, for panning. We don't care about panning. Okay. And this camera rotation. This is for... No, we don't care about these keys. We don't care about this. And this is if camera custom. Oh, camera custom. Wait a minute. No, it's fine, it's fine, it's fine. Fine. And this for orbital. We don't care about this. We don't care about this. Okay, we have simplified update camera just to focus on the like to make the camera be around the player. Yeah, where was this code? Here, like that. Okay, let's run it. Yeah. So currently, right now, we broke the character movement. We broke it, and we cannot rotate the camera. This is what we're trying to fix by having the camera be in third-person mode. By having the camera be in third-person mode, so we can have Steve. So we can have Steve. So where do we use this? This is for camera free. We don't care about this. Here, mouse support. This is where we use it. So here for the camera, we update, rotates the camera around its up vector. Sure, and here we give it a rotate around target. Yes, we are rotating around the target. And how does the code look? If, yeah, this is the code we want to handle. So if it's around a target, we change the camera position. Else, we just change the camera target. Oh, so we leave that. Oh, so third person, we have the target be the same. We don't touch it. We just change the camera position. But if we are in first person, we just change the camera target. Oh, I get it, chat. I get it, chat. So this is the camera up, target position is the camera target, subtracting camera position. Sure, view vector, target position, then up an angle. Let me think about it, chat. Let me open here. So we're moving to the right. Sure, and now moving to the left. Yeah, it's the same code like before. Yeah, it's pretty similar like before. Pretty similar like before. Let me think about it, chat. Where did we handle this? Let's pin this file because we'll need it. Let's pin it. And here for handling the player, we process mouse movement. Here is where we process the mouse movement. We update the yaw and the pitch, and they're like global ones. They're not like some kind of a delta. They're not some kind of a delta. And we have a front, orientation, right and up. And then process movement. We process movement based on all of those values. Nice. And player update, we just update position and handle terrain collision if we're not in creative mode. And then, so what do we do then? Then we get the player camera, we update the position, we always reset the... can I bring it back how it was like before? Yeah, it was like this before. So before, the camera position was where the player position was with a slight offset. And the camera target was, we updated the target to be the player position and the front. Yeah. So we use the player front to update the target. Now it's different. Now for third person, we'll do it differently. For third person, we just need the target to be player position. Player position, we can offset it a bit. Okay, it's fine. Let's just leave it to be just player position. And the thing we need to focus on is the camera position. That's what we need to focus on. We can use the player front. Chat. Yeah, the forward vector. Yeah. Oh yeah, okay, yeah. Jake came into clutch. Yeah, we can. I was thinking the same thing, Jake. Promise, I didn't read your comment, Jake. If you have the forward vector, shouldn't the camera position just be the player position? Move backwards on? Yeah. Yeah, just like I did with the target. I had set the target to use the player front. And here I'll do the same for the position. So we're inverting them. Here. We'll have the position be... no, here we need... let's use the target plus the player front, but maybe negative. Maybe like player front, but inverted. -1. Can I do it like this? Or like, does Raylib have vector 3 invert? To invert the front, like that. And let's see what do we get. Yeah. Chat, something is wrong. Chat, something is wrong. Something is wrong, chat. Where is the editor? Here is the editor. How much time do we have, chat? 14 minutes. Target is the player position, and the camera position is the camera we are adding to the target, the player front. Maybe we need to make copies. Let's temporarily make copies. Let's temporarily make copies. And let's oh, does the vector 3 invert change the player? Yeah, let's look at that, chat. The player, the vector 3 invert, what does it do? Oh, it gives a copy. Oh, no, the invert. Bro, the invert. Bro, what's that invert, man? No. Vector 3 invert is absolutely wrong, man. Vector 3... we need to multiply a value. Multiply. And here -1. Value. Bro, I need a reference. Remaf cheat sheet. Here, let's do vector 3. Like this. So we have scale. We need scale. Scale. Yeah, we need scale. And we can delete this. Yo, chat. But the target is a bit wrong. The target is wrong. It's at the feet. The target is the feet. Yo, chat. We need to change the target and go further back. Also here, like, we can scale it by 5. And we can change the target. Let's change the target to be vector 3. Let's do like this. Let's do like this. Yo. Chat. Steve. We have Steve. Kind of. We need to visualize the collision box. And to rotate the Steve. Yo, chat. Nice. Chat, nice. Bro. Yeah. That's cool. Okay, let's visualize the collision box. Let's visualize it. So that we can center Steve properly. So we can center Steve and to rotate it later on as well. We need to rotate Steve based on the forward vector. So that it follows the camera. And we can, if we have time, we can make it so the head, like rotates first and then the body. Okay, let's visualize the collision box because the player is outside of the collision box. Because if we do it like this, look at this, chat. Player is outside of the collision box for sure. But this is very cool, chat. I'm happy with the result. Happy with the result. It's very cool. On the y-axis, it's kind of fine. On the y-axis, it's colliding well in where the feet are. Where the feet are is kind of fine. Yeah, it's fine where the feet are. The issue is the x and z axis. We need an offset on the x and z. And it's not by 0.5, you mean? No, I want it to be precise. Let's render the collision box. Let's render the collision box. So let's do where on draw, here, draw. Bro, even if you're correct, that doesn't matter. I wanted to see it. Chat, for a main menu, we currently don't have, it's not a priority to have main menu. Yeah, Azure for your offset suggestions, it's fine, man. Even if your suggestions are right, that doesn't matter. My goal is to check it with the collision box. And this stream is the last one for this week, and next week we'll get a stream like hopefully at 25th or 26th. 7 days, chat, 7 days. Let me think about it. Okay, so let's draw the collision box. Let's draw the collision box. How are we going to handle the collision box? How are we going to handle collision box? Like to draw it. Well, we have draw wireframe. We have draw wireframe. Like draw cube wires. And to draw the cube wires, we want position. We want a position. We want a position. How do we get the position? How do we get the position? So for position, what are we going to do, chat? We do player position plus this, maybe, and then collision box size X, and the same on the Z and on the Y, like that. And what else does it need? Color. Let's make it contrast with the terrain. Let's see if this is it, chat. Is this it? Probably not. Yeah, this is not it. Kind of. Oh, it's just the Y. Oh, just the Y. Just the Y. Just the Y, we need it. Let's see the player. The Y is a bit up. Oh no, here. Yeah, I just want to divide it by 2. Just need to divide it by 2. Okay, so this is the player collision box. At least it should be. Yeah, this is the chat. This is the player collision box. Yeah, so let's offset the player. Let's offset the player. Yeah, this is the collision box. This is the collision box. Yeah, let's offset the player a bit. And maybe let's do it. Let's have this be inside of player draw here. Draw collision box. Draw collision box. Okay, sure. And let's see, do we get it as well? Okay. Yeah, we're getting the collision box. Okay, so now let's enter the player. Let's enter the player. And we may need to update the collision box. We may need to make it a bit bigger. Yeah, we may need to change it a bit. Let me think about it, chat. Yeah, let's make the color here different. Let's make the color different. Okay, nice, nice. Okay, this is better. This is better. And let's change the position of the player. Change the position of the model we draw. Let's add an offset here. 0.5, just like chat suggested. Temporarily. Okay, let's do vector 3. Too much. Too much. Too much. Yeah, how was it with 0, 0? How was it with 0, 0? Oh, it's there at the bottom left. We need to move him. This is negative Z, positive Z, and positive X. Yeah, positive Z and X. And how many? Let's use a block as reference. Use a block as reference. We need to move him 1/4 of a block, maybe even. No, chat. Let's just move him half the collision box size. Yeah. Here we'll do 0 on the Y. 0 on the Y. Okay, this should be enough. Yeah, it's based on the collision box size. Yeah, okay. Chat, player, chat. Player. It has collision box. We could now make the collision box be more like in Minecraft, because it's too small of a collision box, I think. I think it's too small of a collision box. Let's see in Minecraft. In Minecraft, we are closer to the player, and oh, I'm holding something. Let's remove the item I'm holding. Okay. Just to have reference. Where is chat? Bro, why are 60 people here? I even removed the music. Excali draw. Every time when I attempt to make the stream more boring, more people come. Why does that happen? I do my best to repel people and more people come. Let's copy here like this, just so we can compare. Let's compare them. Okay, chat. So to the left is my game and to the right is Minecraft. So we need to make it a bit higher, the collision box. It needs to be higher and it doesn't need to be wider. It doesn't need to be wider. It doesn't need to be wider. We can... yeah, okay. Let's make it... yeah, let's change the collision box size. Let's change the collision box size in the constructor here. So the height, let's change the height how much? I use Blockbench as a reference for the height. Here we'll create a new cube. Add element, add cube like this. Where is the cube? Where is the cube? Okay, here is the cube. Here is the cube. It's here. Perfect. Okay. And here I want to test the y-axis. So right now it's 28, which is around here. We want it to be a bit higher. So 1 pixel, 1 more pixel. This is too much. So 30. Let's do 30. Here, 30. Let's do that. Yeah, okay. Okay, now it's... now collision box should be like Minecraft. It should be like Minecraft. And our next focus should be... I think here it's easier to see. Let's make the camera closer. Let's make the camera closer. Here, so the distance to be 3 blocks distance. 3 blocks distance. Sure, now we are a bit closer. And look at how the collision box is at the hairline. How is it in Minecraft? Hey, we can see. Oh, chat, we found a problem. Yeah, well, let's say it's at the hairline, but we found a problem, chat. Look at how here in F5, we never look at the front. Oh yeah, because we're not rotating the player. Yeah, let's rotate the player, chat. Let's rotate the player. Yeah, let's rotate the player. Let's rotate the player, chat. Let's rotate him. Yeah, let's rotate him. How are we going? The model should follow the front vector. It should just follow the front vector. Kind of. Ignoring the y-axis. And the head will have the y-axis. Let's do that, chat. Let's rotate the model. And we rotate it when we draw it. We rotate when we draw. So let's go to the player, draw. How much time do we have? Oh, time is up. We'll push it a little bit more, just in case, without a timer. Without 1 hour has passed. We'll push it a little bit more and see what's up. But without a timer. Now we are without a timer. Hopefully we can finish something here. Now we're trying to finish, to have a finished state. That's what we're trying to do now. We need a finished state. So when we draw the model, we want to rotate it. Timer is to signal we need to move to a different feature, to a different segment. We want rotation. Oh, here we want this. We want this. This we want. A more advanced drawing. A more advanced drawing. Here, this is player model. This is position plus... bro. Plus this. Plus this. The tint color is white. White. The scale is 1. The scale is 1. And rotation. Rotation axis, we can do the y-axis. We can do the y-axis. And for the angle, let's do the... Is it the yaw or the pitch? Or maybe... Let's do yaw. I'm not sure which one it was for the rotation. It's rotating, but we need it to be a bit different. We need an offset and to invert it. It's rotating, but we need to chat. We need to invert it. Oh, do we need to put it in radian? Does it need to be radian? Or does it automatically do it? Oh, it converts it from degree to radian afterwards. It does it afterwards. Okay, and let's invert it now. Okay, now we are just looking at the side. Let's invert it by 90 degrees. Let's add 90. Plus 90. Let's plus 90. No, minus 90. Minus 90. Minus. And we should have the player. Okay, chat, we have player, chat. We have player. We have player, chat. And it's colliding with the world. Colliding. Sure, that's cool. Yo, chat, player, chat. But without animations. We don't have animations. Bro, the hitbox should never rotate because we have axis aligned collision detection. The collision box should stay aligned with the other cubes because if you have rotations, that makes the collisions more complicated. We should never rotate them so that the algorithm is much simpler. It's fine, chat. But we have Steve, chat. We have Steve. Yo. So, chat, do we try to do animations? Do we try to do animations, chat? No. Let's just have F5. No, chat. Let's do F5. No animation. No. F5. We do F5. Let's have F5. Let's have F5 mode. Because we need to bring back how it was before so that we can implement this change in the main branch. Yeah, let's do F5. So that we can implement it with the code. Because if I leave it like this, we will not be able to implement other stuff. I want F5. So how are we going to handle F5? As a state, like enums, like the... How are they called? First person, third person? What's the naming in Minecraft? Third person. What's the naming of the modes? Of the three views? Third person. What's the name when you look at the front of the player? What's the name when you look at the front? I need a name. Doesn't matter. We'll figure something out, chat. We'll figure something out. Okay, let's do F5. And let's commit this. How are we going to call this? Third person view. Yeah, we can have third person front mode. Okay, let's have player. player. Let's have structure, no, enum class, view mode, camera mode to be first person, third person, and third person front. And F5 will toggle between them. F5 will toggle between them. And in the and here let's have camera mode. And by default, it will be camera mode be first person. It will be first person. So what now, chat? Well, when we are drawing, think about it. We will draw Steve. We'll draw Steve. If camera mode is not first person. If it's not first person, that's when we'll draw it. And int rotation offset will equal, let's do it 0. And here, if camera mode is third person, else. So if it's third person, we do minus 90. Else is just 90. So we look at the front. This is for the front. Here we do plus. We do plus rotation offset. We do rotation offset. Okay, fine. This is good. So what next? And we need to update the camera properly. We need to update the camera properly. Player. Where did we handle the camera? Here. If player camera mode equals first person, player camera mode first person, if and else like this, like this. So now we should be able to have all of the modes, but let's process the F5 key. Let's process the F5 key in the on update, let's say. Let's do on update. And here let's do if key down, key F5. And here we cycle through the modes. Let's go to the player and make the modes be integers. Let's make them be integers so we can cycle them easily. And the first person will be 0. First person will be 0. And here we can do invalid view, invalid mode, so we have an end. And in the game, what do we do? When we press F5, we do player camera mode plus equals 1. Can we do that? Let's get it as an integer in some way. Cam mode equals, let's get it as an integer. Okay, mode plus plus, we increase it, and if mode equals player camera mode invalid, if it's invalid as an integer, if it's invalid, we reset mode to be 0. And then we do player camera mode equal mode. And we need to convert it. We need to invert it. So now we should have F5. Hopefully. But let's see if there is a compilation error. So default should be first person. Yeah, default is first person. We are not updating the bounding box, but we don't need it right now. We don't need the bounding box. Default is first person. Let's go in draw. And here, let's just comment it out. We don't need the bounding box. Okay, default is first person. Nice. And so now when... Oh... We are way higher up. I should change the camera. Camera is too high up. I should change the camera. We're way high up. Wait. Why are we floating like... I'll test it later. I'll test it a bit later. Well, let's do F5. Yo, F5. Steve. It's moving too fast, chat. Like, it's like holding. It's not if key pressed, it's like key held. I should do key pressed. Yeah, is key down. Is key pressed. And that should reset it. Okay, chat, we should have F5. F5, F5. Yo. Oh, bro. No. F5, the front view rotates the player. No, that's wrong. We should rotate the camera. No, that's wrong. No, chat. That's a mistake. No, let's go to the player. And when we draw the player should always be rotation offset to be -90. It's fine. This should be -90. That's fine. And let's remove this. Nice. Yeah, so we need to do it where? In game layer. Here. We need to do it here. This is first person, this is third person. Here we do float cam position scale equals -3, and if the player camera mode equals player camera mode third person front, this should be not negative. It should be not negative. It should be... No, let's have default like this. Here third person, and here multiplied by -1. That should be better. Multiplied by -1. So now it should be better. Somebody asked if the hitbox should rotate. No. There is strong push for F5 and animation. Oh, hand animation. We don't focus on hand animation right now. We're not doing that. Modding. We don't have modding. And we're not doing 3D export. To make the crosshair disappear. That's interesting. Now we don't have the front view. Why don't we have the front view? Oh, because we're not using it. Okay. Yo, front view, chat, front view. Should we remove the crosshair? Okay, we should remove the crosshair. Yeah. Let's remove the crosshair. Let's remove the crosshair. Where do we draw the crosshair? Oh, in the UI layer. Oh, but UI layer doesn't know about the player mode. UI layer doesn't know it. We'll figure something out. Crosshair. Where's the crosshair? Is it in game layer? No. Is it? Crosshair. Oh, it's here. Interesting. Yeah, draw texture. Here we do if player camera mode equals first player camera mode first person. If it equals first person, that's when we have the crosshair. Yo, chat. Yo, chat. What's up? What's up? What's up, chat? What's up? Yo, this is a thumbnail change, chat. Let's change the thumbnail. Let's change the thumbnail. So that people know what's up. The previous one was better, but doesn't matter. For screenshots I use, what was it called? Forgot the name. Light, it was light something, light shot, something like that. Slide shot. Let's check in first person how it is. Yeah. Collision box is... yeah, we need to update... Yeah, let's fix first person and then we'll move to a different feature. Let's fix first person, chat. Let's fix... what's wrong with the first person mode? What's wrong with first person mode? What's wrong with first person mode? The camera position is player position plus collision box stuff. Oh, we had the offset. The previous offset. No, now it should be fine. Now it should be fine. Yeah. Now... Yeah, now we properly collide. Okay, chat, we have F5, chat. We have F5. We have F5. We have F5, chat. Nice. We have support for F5 cycling through the camera views. That's cool, chat. That's cool. That's cool, chat. The animations are for some other time. Animations are for some other time. I don't care about the collision box. It's fine. It's fine, chat. We don't want collision box. Fine. Head movement is fine. We don't need it now. When we do animations, that's when we do head movement. Let me save this. F5 cycle through camera view modes. Okay, so chat voted. So this was the first feature. We'll do another feature. So let's do another 1 hour timer. Another 1 hour timer. And before that, let me do a summary of what we did for the previous feature. So chat voted for a feature for the first hour of the stream. So chat voted for the player model. With a 1 hour limit, we went a bit over that. we added this F5 camera cycling, and we have the Steve model here. We have the Steve model, and which actually follows the camera rotations, everything is nice. The only thing we didn't have time for was the animations and the head movement. But that's fine. That's for a different time. Now we will vote for a different feature, and we'll do a 1 hour timer and see what happens. But yeah, but this was adding Steve. 3D Steve. Yeah, this was worth it, chat. This was worth it. Let me think of features to add, chat. Where is chat? Where is chat? To create a poll here. I need to create a poll, chat. Let's do a poll here. What to do now? So what are the options, chat? We have lava, liquid, physics, and mesh. We have villagers. What else, chat? We're not ready for player animations. That's for a different time. We're not ready for player animations. What are we adding, chat? I want 2 more options. Weather, rain, snow, weather. And 1 more options, maybe fireworks. What should we do, chat? What should we do? A day and night. To finish the creeper. Creeper. Finish creeper. Creeper. Pathfinding and explosion. So to follow Steve, that would be cool. Day night, bro. Day night. I'm not ready for day night. I'm not ready. I don't want to make the multiplayer mistake. We're not doing the multiplayer mistake. Let's vote between these options. Chat, you have 4 options. 4 options are enough, chat. We have enough options. So I'll put another 1 hour timer where we'll attempt to implement something. And the options are lava, liquid, physics. So just like the water. And with the improved mesh. And we'll make the lava collide with the water to make cobblestone. I think that would be fun. The other option is villagers. But for villagers, we will need to create a bed. And to have them go to the bed and walk around the village. That would be difficult. For the weather, rain and snow, it will just look cool, man. It will look cool, the rain and snow. Creeper, pathfinding and explosion. We already have a creeper entity. And we attempted to do pathfinding. We just need to finish it. So, and we have TNT, so we have explosion. So each one of these options are good ones. Each one of the options are good options. And we'll have 1 hour timer, chat. So we have 1 hour timer. How many votes do we need, chat? How many votes? We are 60 people and we are at 36 votes. We want we can reach 50 votes, chat. I think we can reach 50 votes. We are 60 people. We can reach 50 votes. Because it's very close between weather and adding creeper. No, we're not going to try Godot. I want to finish the project. I don't want to jump around. I want to finish the project. I will not leave this project. I want to finish it. I'm all in the project. Because this is already the 6th clone probably, or 8th clone. I don't know. We've done enough clones, chat. I was thinking to do Godot, but we talked in Discord and I changed my mind. We had a few ideas in Discord and I changed my mind. Okay, we're waiting for five more votes, chat. We need 5 more votes. We are at 45 votes. I need 5 more votes, chat. 5 more votes. Four more votes, chat. 4 more votes. For lava liquid, we can try to make it collide with the water and make cobblestone. Villagers, I'm not quite sure how we'll do them. They will be difficult. Weather, it will look really nice if we manage to do it. We already have particles. Hopefully they use... I don't know if they use particles or not. Creeper, we did an attempt. We just need to finish it. And it will be cool, the creeper going towards the player and just blowing up. Because like, bro, what's Minecraft without a creeper? How can a Minecraft clone not have a creeper? Okay, 1 more vote. Okay, we have 50. We're ending it. Okay, so chat voted for... So chat voted for the second part of the stream to do weather, rain and snow. That's what chat voted. To weather, rain and snow, chat. So for the first part of the stream, we added the 3D Steve, the F5 cycling. We have first person, third person, and third person front. And for the second half of the stream, chat voted to implement the weather. Chat voted to implement the weather. So let's add a timer. We have a 1 hour timer. And let's do it, chat. Let's do it. What's the worst that can happen? Let's implement the weather, chat. So every time we just go in Minecraft. And we just test it here. Weather, rain. Let's do rain. So this is the raining weather. This is when it rains. This is when it's raining. We need... I think we need a Raylib. I think... no, let's just... We have a cool shader that helps with debugging. Let's just first use the shader. Yo, chat. This should show the wireframes. What are these wireframes, chat? This should be for the... Let's clear the weather and see if these wireframes disappear. Weather clear. They disappeared, so that's the weather. So they have these meshes then. Weather, rain. So they have these meshes. And what are these meshes? Interesting. And they stay statically at the same spot. Yeah, they're for the... Yeah, they're probably for the raindrops. Like what else? And... No. They... Look at how the center where the player is, they disappear a bit. That's interesting. And they change a bit. Look at how some of them rotate a bit. Let's do... let's slow down the game. Game. How did we slow? I forgot how we slowed down the game chat. Bitrate killer. Yeah, it's bad for the bitrate, but the priority is to implement something. Rate, set, rate. Tick, yeah, tick, rate, 1. So now it's slow motion, chat. Now it's slow motion. Each raindrop is in slow motion. Let me think about the chat. Okay, we need Raylib. Why is Minecraft like that? It's a hack, man. It's a hack. Yeah, let's open Raylib. I need help. Let's open render doc. Yeah, sorry, man. My bad, chat. My bad. Lunch. Launch Minecraft. Yeah, we have F5. This is F5. We have F5 chat. Not fully implemented, but it's enough. I'm happy with the result. Videos have texture packs. Bro, I cannot change the texture packs in the videos. Whatever you see in the videos, it has been in the stream. Whatever has been in the video has been in the stream. Yeah, but this 3D Steve is cool, chat. It's cool. I like the change a lot. It was worth it, chat. It was worth it. It was worth it to add it. But let's look at Minecraft. Yeah, the videos are a bit behind, but in the 7 days where we will not have a stream, in the 7 days without a stream, I'll push out a lot of videos, hopefully, if my laptop can handle rendering videos. But hopefully I'll be able to render a lot of videos in the 7 days. So we'll be catching up with the videos and the streams. There'll be many videos, chat. Many videos. At least we'll have that. Rain. Okay, now we have rain. And let's make a screenshot. Let's have a screenshot. And let's see what's up, chat. Let's see what's up. What does Minecraft do for handling the rain? No, original has more FPS. The original has more FPS. How are we going to handle the rain? Let's enable highlight draw call. It's in a single draw. Bro, they do it in a single draw call. That's interesting. And they use this texture. They use this texture. This is the rain texture. They use this texture. Interesting. Interesting. Output. This. Wait, where are they? It should be this, right? I missed them. Where are they? Did I break something? I broke something. Where is the rain? Where is the rain? Bro, where is the rain? Oh, I'm looking at the wrong output. I'm looking at the wrong output. I think. Right? Okay, this is it. This is the rain. This is the rain. This is the rain. And these are... Yo, this is a single chunk, chat. That's a single chunk. A sub-chunk. That's a sub-chunk, kinda. That's a sub-chunk. And they're using billboards that are billboards towards where the player is. Maybe. They just have billboards. And the center is where the player is. They're just doing billboards. Yeah. They're just doing billboards. Many of them. Many billboards. So how are we going to handle this? Okay, we can, in a circle around the player, we can focus on the positions, and in a circle around the player to create all of these positions. Sure, we can do that. We can do that. No, but look at how it's a square here, so that we can do it in a single subchunk. Yeah, it's more like a square. Yeah, it's a square. It's a square, chat. It's a square. How many per side? 1, 2. Yeah, let's screenshot this. How many are there? How many? How many, chat? Let's count. So we have 1, 2, 3, 5, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So 21 by 21. It's not one per block, because if it was one per block, it would have been 16. 21 by 21. Yeah, let me count the upward, the other side as well. Here it's 1, 2, 4, 5. Let me count in Bulgarian, it's simpler. No, dve. And let me remove this. Let me do it from below here. No, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 17, 18, 19, 20. No, same count, 21. 21. It's 21 by 21. Chat. It's 21 by 21. 21 by 21. And they always... Yo, this is interesting, chat. Okay, and let's find the texture. Like, I want to look at... I want to look at the texture, the sprite, the rain texture. I want the rain texture. So I should go in my backup folder. Then vanilla asset. Okay. So let's look for rain. Let's look for rain. Yeah, we have this rain PNG and this rain JSON. So 0, 1, 2, 3. So maybe this signifies the animation. Splash. Oh, this for particles maybe. Splash. Let's search for splash. Yo, these are splashes. So like When do we use these splash? Oh, when they fall on the ground, the splashes, bro. Imagine if we do the splashes. Oh, that would be sick, man. If we have these on the ground. The splashes. When the rain hits the ground. That would be interesting. Oh, chat. That's how they... I was wondering, chat. I was wondering why the meshes looked like this. Look at this, chat. Look at how the meshes are... Some of them are a bit higher up. And I was wondering why. And it's because of the splashes. It's because of the terrain. It just ends here. That's why there is a difference. It just ends here. It just ends here, chat. Let me stop the music, maybe. It just ends here, chat. That's why. So that at the end where this ends, they can add the splash. So they can add the splash here, chat. Okay, we can do this, chat. We can do this, chat. We can do this. At the top is the same. At below, there's a different height. It's 10 blocks on either side of the camera. Oh! Oh, so from here, 10 blocks to this and 10 blocks there. That's why it was 21 by 21. So that's why it was 21 by 21. No, it's like... so chat is debating whether it's sprite or particles. It's like both. Like... It's the rain texture is like a sprite here. It's a sprite. Here, rain. Where is the rain? Here, sprite. This is the rain texture. It's a sprite here. We can open it in the atlas. Yeah, this is the rain, chat. It's a sprite. And we'll just use it. It will go from up to down, probably. It's fine. We'll see how we'll do it, chat. We'll see how we'll do it. And it's also particle because look at how it's the same like the particle, because particles look at the where the play. No, it's different from the particle. It's not a billboard. It's different from the particle because look at how if it was like particles, when it would particles. The rotation of particles depends on where the player is looking. But the rain is different. The rain uses the player position for the rotations. It's different, chat. It's a bit different from particles. And they don't have collisions with the terrain. Those are the differences. Because particles collide with the terrain. They collide with the terrain and they always look at the player. So if we do the fireplace, if we do the campfire, and you can notice how particles, look at how they rotate to the, depending on the player, where the player is looking. This is particles, chat. But here, the rain uses the player position. It doesn't use the player look. The player where the player is looking. Okay, let's do this, chat. Let's do this. And how much time do we have, chat? How much time? We have 45 minutes, something like that. We have around 45 minutes, chat. I'm reading the chat, man. I'm always reading chat. You are discussing Easter eggs. That has nothing to do with rain, bro. Bro, I'm always reading chat. I cannot open source the project. A sphere emitter. What's a sphere emitter, chat? My language is Bulgarian. And sound, I don't know about when sound will be added. I don't know about sound. People need to vote it. It needs to be voted, and that's when we'll have it. That's when we'll have it. But what the sphere stuff? The sphere emitter. What's a sphere emitter? Sphere emitter programming. What's a sphere emitter? Also, it's like from the engines. So engines have sphere emitters. Let's do Raylib. Yeah, I want to make 3D sphere particle system using Raylib. Sure, I want to do it as well for the rain. How should they? It's fine. It's fine. What's this? What's this example? No, no, no. Bro, chat. It's not a sphere, chat. It's not a sphere. It's a square. Like we can go around the player, and each one is above a block. Each of the rain stuff, each of the rain quad is above a block. It's above a block. So we will be doing in a 20 by 20 region around the player, something like that. Or like 21 by 21 region around the player. And we'll spawn over each block these stuff. Over these blocks we'll do. Yeah, we have the algorithm. We have the algorithm. For splash sprite at ground level, I'm not sure if we will have time for that. I'm not sure. But we'll see. We'll see. Okay. Where's the game? Here's the game. Bro. Steve, the physics breaks when delta time has been gone for a long time. That's why it breaks. But when you are playing the game, it's fine. Okay, chat, I need 2 minutes. I'll be right back and we'll do the rain stuff. I'm back. I'm back, chat. Let's do the rain, chat. Let's do the rain. Let's do the rain, chat. So, okay, let's do a 21 by 21 region around the player and create these billboards and let's make them rotate to face the player. That's it, chat. It's very simple. And let's, in the beginning, just draw them with some kind of a default texture. I don't know. Some kind of a default texture. No, chat. Let's do it differently. Let's have a static position. Some kind of a static position. And just spawn them there. That's not the player, so that we can fly around them and look at their rotation. So we can look at their rotation. We can even draw them as wires. We can even draw them as wires. But we'll see. We'll see. We'll see, chat. Let's pick a. How are we going to do it? How are we going to do it? Well, we need to render something, so let's go on render, and there we'll have all of the logic. We'll have all. Let's pick a place actually. Let's pick a spot. We'll have it be where, chat? Where should we have the rain temporarily? in a one spot. We can have it here. We can have it here. Somewhere here. So we can do 9, 107, 25. Nine 107 25. Spawn rain here. Let's spawn the rain, chat. I don't have an end goal, chat. I don't have an end goal. We're just... My goal is to invest 300 hours making this project. And I want to see what happens after 300 hours. And then I'll decide what I'm going to do. Whether to start a new project or to continue this, maybe a multiplayer version. But we'll see, chat. We'll see, chat. But right now we're at around 170 hours, 170 I think. So we're still not there yet. We have a lot more hours to go for 300. Because I want to make the same video as my previous one, where I did a video 300 hours making Minecraft clone. I want to make a part 2. It's 100 streams. Yo, yeah, it's 100 streams, you're right. It's 100 streams. Okay, let's spawn rain here. How are we going to do it, chat? How are we going to do it? Well, we go from the sky down. We go from the sky down and we need a region around this point. Are all at a fixed rotation and fixed offset from the camera. No, rotation is... yeah, it's fixed, but if the player moves, rotation changes a bit. Fixed offset from the camera. I think it's also double-sided. No, it shouldn't... No, it's not double-sided, because it follows the player. You'll just spawn it again with the proper rotation. Oh, but then it breaks the animation. Then it breaks... No. Then it breaks the animation. Yeah, look at how it's continuous. Yeah, it would break the animation if we... Yeah, we'll see, chat. We'll see. Bro, we'll see. Let's do the... Bro, we don't have time, chat. We don't have time. We have 30 minutes, chat. We don't have time. Let's not get distracted. Let's focus, chat. Let's focus. So, let's spawn around... Okay, we have... Where should be the rain position? Let's do here. Vector 3. Rain position spawn point. Let's do this. Let's do 9, 1, 7, 25. Let's do that. My RAM is like around 64 gigabytes. But that was before the price increase. I was lucky. Ask Bog about that. Don't ask me, man. I don't know. If I get invited, I'll accept. Yeah, okay, let's do this, chat. Let's do this. So we do for int x. We need to go around this position. We don't care about fog color, it's fine. Should be around the player, like a circle instead of being far away, which will cause lag. No, it's not a circle, chat. It's not a circle. Just go back in the vote, you'll see. It's not a circle. Square. It's a square, chat. We need to go around 20 by 20 blocks. Around, or like, how should we do this, chat? Like here, 0 and x less than, we can do 21, it's fine. And here the same for the Z. Same for the Z. Okay, sure. And we need to draw at these positions certain things we need to draw. We need positions, chat. We need to go from the top to the bottom. We need to first gather the positions. We need to gather the positions, chat. So we want, so how many positions? It's 21 by 21 positions. So it's 21 by 21, 441. One quad per column. Okay, let me think about it, chat. We need to do it. We need more stuff here, chat. We need an array of positions. Rain billboards positions. And it's 21 by 21. We need to calculate the positions. And let's have this rain spawn point. Let's have the rain spawn point position. And let's go on the we need to do it once, maybe. We need to do it once. Or on update. When should we do it? Or like with the press of a button. Yeah, let's do it with the press of a button. Let's do it like that. So that we calculate the positions only once. So how are we going to attempt this? On update. Yeah. And if is key pressed, we'll do key F7. We'll do F7. And here we'll update the positions. Here we'll do the positions. We'll do the rain positions. Let me copy what we wrote before. Here, let's copy this, even if it's not that much. Let's move this to the on update. Move it to the on update. And here when we press F7, let's calculate the positions of the... We can call them particles, it's fine. The rain particle. Let's calculate the positions. How are we going to do that? We need a starting point. We need a starting point and to go down until we find terrain. That's what we need to do. So we need... How are we going to do it, chat? And here let's do int index equals 0, index plus plus. And here we do rain positions index. And here we need the position. We need a position, chat. Bro, I'm not giving it gravity. That's stupid. Like, that's inefficient. Right shift so it's easier to press. It's fine, chat. It's fine. It's fine if it's F7. Like, the priority is to do it in time. So let's calculate. Currently, we need to calculate the ground, the terrain positions. We need to go from the sky down to find all of these block positions. That's what we need. And above them will be the rain positions. Above them we'll have the rain positions. That's what I'm doing currently. That's what I'm doing. Raycasting. That's also a good idea, but I just go block by block down. It's fine, chat. It's fine. So here, let's do... here, let's do position details starting position equals the starting position will be, what will be the starting position? It will be, let me think about it, chat. It will be the rain spawn point, the rain spawn point plus vector 3. Okay, let's do this. Vector 3 start position equals, let's move it here. Start position. Start position, starting position, brother. Details. The start position is the spawn point plus x, 0 and z as floats. And start position y equals, let's do it 256. Let's do 256. Let's do 256. We start from here and we need position details equals, I have a function for this to get block type damn it. Let's just go down. Yeah, that's a good summary. Let's go down. Here we do while position details block type is air. Does the rain go through the foliage? No, I'm just making it around the player. It's not everywhere. It's not everywhere. Does it go through the foliage? I think not, chat. No, it does. It hits the ground. So it needs to go through air and foliage. Let's just do air for now. It's fine. Let's just do air for now. If block type, while block type equals air, we go down. So here we do position details, go down. We continue to go down, and here we need to go up. Once we find the ground, we need to go up, and here the billboard position will be the block origin. It will be the block origin. So we should have all of the positions. We should have them. We should have them, chat. And in all of those positions, let's render something. Let's render something in all of those positions. How much time do we have, chat? We are at 24 minutes. We're doing all right, chat. So when drawing, where here. So here, let's do also a boolean, a flag. Boolean draw rain equals by default false. And on update, once we press F7, then draw rain equals true. Just temporarily. And we do on render here. If draw rain, we go over all of the positions. So for vector 3 position in rain positions like this, we go over all of them, and let's draw something there. What should we draw there? A circle, sphere. Draw sphere in the rain position, radius of 0.25 and white, like that. Let's see if we get the positions right, chat. see if we have the positions right. So let's do F7. Okay. Oh, chat. Oh, F7 is for me to go in, like, to go off creative mode. Yeah, these are the positions for the rain. And so let's say the player is somewhere here in the center. Let's say player is in the center, and around here we'll have the rain. We'll have the rain around here. And we want to render the rain spawn point. Oh, I think the rain spawn point is around here. We need to center it. Let's make some changes, chat. We need to change here to be, we can do right shift. Let's do right shift as a button. And also here also let's draw sphere in like purple. In purple, the starting position, the spawn position, the rain spawn point. I want the rain spawn point as well. I want the rain spawn point. Okay, nice. So this is the rain spawn point, and let's say like this is the player position. So we're spawning the rain, and currently it's not centered. It's not centered, and the origin for the rain needs to be in the center of the block as well. So we need a global center, the spawn point to be in the actual center, or like to move all of these dots more towards here. So towards the negative X and negative Z. We need to subtract from their positions and to center them, and then we'll spawn the rain. Yeah, this is a good spot for a screenshot. Update. I was gone for 5 minutes. Let's update screenshot. Yeah, I updated the thumbnail. Where is chat? Where is chat? Here is chat. I'm not using ray casting. I'm just starting from the top block and moving down. And yeah, we are doing radius around the player. It's fine, chat. It's optimized, kind of. And memory usage, render distance, I'm not using Minecraft render distance. I'm just rendering like, I think, 20 by 20 subchunks. It's not hard if you use CMake. We're doing crane, chat. We're doing crane. We're doing crane right now. Okay, let's center. These are the rain spawn points. Let's move them to be towards in that direction, so that the spawn point, this is the spawn point, so it's in the center, so that we can have rain around the player. And yeah, we may need to update them, like chat suggested, because now they stay in there when we break a block. But that's fine, chat. That's fine. That's not a priority. It's fine. Let me think about it. Let me think about it. Okay, we need to change the positions. We need to change the position of the rain that we spawn. You can add a cylinder around the player in your project. Don't worry about it. I'll do it like this in my project. Let me think about it, chat. Okay, let's change the positions, chat. Let's change the positions. Here, we want to not be X and Z. We want, how should we do it? How should we do it, chat? We need to offset them. Yeah, okay, here int size equals 21. Size, and here we do minus. Let's do 20, chat. Let's do 20. Let's do minus. I'll think about it. Size divided by 2. Size divided by 2. Here minus size divided by 2. And let's see what's up. Of not this. Okay. So now it's should be centered. Nice. Okay. And now let's make these spawn locations be at the center of the block. Let's make them be at the center of the block. And yeah, let's do that. Let's make them be at the center of the block. How? Well, instead of giving block origin to oh no. Let's temporarily remove this offset. Let's temporarily remove it so that I can be sure I'm centering them. Yeah, let's first start it like this. And okay, nice. So this is where they start. This is where they are. I want to move them in the positive. Okay, so plus. Vector 3, 0.5f, 0, 0.5f. So now they should be centered. Nice. Are they? Yes. Yeah, they are centered now. Perfect. And how much they are? 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 12, 13, 14, 15, 16, 17, 20. We want them to be 21. 21. And let's make them centered around the spawn point. Okay, nice. Okay, so let's see what's up, chat. The position is, I want this position to be at a certain block. So let's make the position be here, kind of. Right? Around. Okay, let's move this spawn point. I don't want the spawn point to be at a crossroad. I want to see which exact block this point is. So let's change its position a bit. Let's change its position. Let's change the position here. So here on the X we do 0.5 and 0.5 here. This should center it. Yeah, okay. So this is the center. This should be the center. Let's see if it's actually the center. So 1, 2, 4, 5, 6, 8, 9, 10. Okay, we have 10 there, and we have 1, 2, 3, 4, 8, 9, 10. Perfect. This is actually the center. Let's remove this spawn point, this position. Here we don't need rain where the player is. We want rain around the player, only around the player. So let's remove this point. How are we going to remove it? Because they're exactly 21 by 21 positions. We'll see what we're going to do. Here, we need to test if x equals 0 and z equals 0, we continue. Or like here we do, what do we do, chat? Should we like continue? No, let's set up a position. Here, let's set up a position. Here, position by default will just be zeros. Or like, I don't know, chat. Like negative 256. Like 0, negative 256, 0. Some invalid position. Invalid position. Let's just say. Some invalid position. And we'll just continue on. And here, continue. Like that. So the center block should not have rain. Center block should not have rain. Is there a spot missing? I don't think so, chat. Oh, this spot is missing, so this is 0, 0. Oh, yeah, it should be with the offset. Should be the offset. Yeah, chat. Float. Damn it. Let's just move this here. And if start position equals rain position spawn, if they equal. Now, yeah, okay. Now we're excluding the center. The center is excluded. Rain grid is now centered on the player and the center block has been excluded. Where the center block has been excluded, and if we set this to be the player position, it should be pretty close. Okay, so now let's spawn the rain. Let's spawn the rain. We have the rain position. Not when I send them. We were pretty close, man. We were pretty close. Okay. So, yeah, it predicts the future, man. It's a bit in the it's an advanced model, man. An advanced model. It predicts. Yeah, that's a future summary. Let me think about it, chat. Okay, so now we need to draw these meshes. This is what we need to draw, chat. This is what we need to draw. Once we have this, we'll have the rain sprite on top of them. Like these are the meshes, these are the quads. They need to rotate towards the player. All of them need to be rotated towards the player. And what else? And we need to use the rain texture. The rain texture. We need to use the rain texture. And Gaming Studio about the alpha fading based on distance and intensity, that's for later. But be sure to remind me if we forget. And for simple mobs and AI, we are not doing it today. We're doing Crane now. We're doing Crane. Okay, let's draw these billboards. Let's draw the billboards. Let's draw the billboards. Let's draw them, chat. Let's draw them without caring about the rotation for now. And how high should they be? How many blocks high? Let's just do 16, it's fine. Let's just do 16. So currently, we are spawning, we are calculating. Once I press Shift key, we calculate the rain spawn positions. We'll spawn the rain around these blocks. That's what we're doing. I'll do a summary for you. I'll do a summary. Summary. do summary for you. Okay, chat. How are you handling the animated textures again? Give us a rundown. That's for another time, chat. We're doing crane now. We're doing crane. Let me think about it, chat. Okay, so we have the spawn positions for the rain. Let's now draw the mesh that Minecraft has. Minecraft does this for the rain. When there is rain in Minecraft, you get all of these quads. We need to draw them. We need to render them. Let's do that, chat. Let's do that. So we render these spheres just to be sure we have the right positions. And we are certain we have the right positions. We are certain. Let's now draw at these positions this mesh without the rotations. Afterwards, we'll draw the rotations. Afterwards, we'll draw the rotations. So let's do that, chat. So where should this logic be? It should be... How much time do we have? 6 minutes. We may need to push the time. Spheres looks insane in Minecraft. Yeah, you're right. You're right. Yeah, okay, on render. Let's go on render. Let's go on render, and here we draw all of the spheres. This is where we draw them. This is where we draw them. Instead of drawing spheres, let's commit this actually. How should we call it? Calculating rain billboard positions. Calculating billboard positions. And what next? What next, chat? Okay, instead of spheres, we need to draw something else. We need to draw something else. Draw. We have billboard, which is for particles. It's for particles. Draw billboard, which takes in a camera, which we don't need to do. We don't want a camera. Because billboard uses where the camera is looking at. We don't want that. We don't want that, chat. Even the pro version uses a camera. We don't want that. We need to do something else. Draw. What else can we draw, chat? What else can we draw? Let's look at Raylib cheat sheet. And draw. Let's look at drawing. Let's see what we're allowed to draw in 3D. We have draw texture. We have draw texture. We have draw text. Okay, here, drawing in 3D. We can draw a line, a point, circle, triangle, a cube, a sphere, cylinder, capsule, plane, ray. Okay, let's just draw cube wires. Let's just draw that, and we'll set like the width to be 0, something like that. Okay. Now we can draw cube as well. Draw cube. We can draw cube. And position, we'll use rain position. Then the width, let's do 0.5. For height, let's do 16 blocks. And for length, let's do 0. And color white. Let's see what we get as a result. No, not Billboard Pro. That uses the camera where the camera is looking. That's wrong. I think. Chat, is that wrong? Is it wrong, chat? Yeah, we're drawing the meshes. We're drawing them. We can make them wider. We can make them wider. We can make them wider. And they should be here where the player is. And we'll set them to use the rain texture. We'll set them to use the rain texture. Let me think about it, chat. Yeah, maybe we can do the billboard. Because we use the billboards for the particles here. We use them for the particles, the billboards. which use the camera rotation. But look at this chat. Look at here how if they did that, if Minecraft was doing that, if Minecraft Terrain was using billboards, they would not have been rotating like this towards the player position. They would have been rotated in a single direction. That's why I avoid billboards, chat. Here they're rotating towards the player position, not where the player is looking. It's different, chat. It's different. If it was a billboard and the player is looking like this, look at this, chat. Bro, it's not a bill. We're wasting time, chat. Chat. We have 2 minutes, chat. We're wasting time, chat. It's fine, chat. It's fine. We're wasting time. We're wasting time. Let's do here cube wires. Let's do cube wires. And let's make them wider. Just to test. And they need to be rotated toward the player position. Here, like this. Okay, we have the wireframes, just like in Minecraft. Oh, we need... no, it's fine. Here we would need... rain position, we would need to change it. Rain position, why? Because draw wires is centered. So we need to offset the Y. Like here we need an offset. So plus 0, 8, 0. Vector 3. We need an offset. Just because of how they draw it. Yeah. Yeah, so now they are perfect. Now we need to rotate them towards the center. Towards here, the center. We need to rotate them here towards the center. That's what we need to do. Let's do that, chat. Let's rotate them towards the center. How can we make them to look towards this direction? How can we make that? How can we do that, chat? How can we rotate them? And we need a texture. Can't we change draw billboard? Can't we change it, chat? Let's temporarily use draw billboard. Yeah, let's temporarily use draw billboard, and so that we can make our own custom draw billboard. Let's temporarily use this. We will need to change it for sure, probably. Well, let's see, chat. Let's see. We have camera. So we have world get player camera. And for texture, we need the rain texture. We need rain. And we don't have it in the texture atlas, I think. Is this in blocks? Or can I find the file location? No, it's in environment. Let's copy and let's add it in. Let me think about it, chat. Yeah, we need to go in resources. Here, textures. And let's just copy it here. Rain PNG. Textures, rain PNG. And so in game on attach, Let's load the texture. Rain. And here, rain PNG. Let's load the rain PNG and let's use it here. Billboard. Let's do world get texture. Rain. The rain texture. Position will be rain position. And scale will be 1 and no tint. Let's see what's up. Where are they? Yeah, we're spawning them. Oh. Oh. It's drawing small droplets. Very small droplets. It's drawing. And look at how they rotate based on the where the camera is looking, which should be wrong. It should be wrong, right, chat? It should be only the player position. Let me open another Minecraft temporarily. Let me open another Minecraft. The 1 hour is over, but we'll push it a bit more. We'll add like 15 or 30 minutes, just so we can have something finished. Yeah, here. Look at this chat. Let's look at the wireframe. Look at, does the wireframe rotate based on the camera? No. Look at this chat. They stay the same. But if we move the player, they change. It's like that, chat. It's not a billboard, chat. It's not a billboard at all. It's based on the player position. This is not a billboard. This is not a billboard, chat. And how do they do the raindrops? Now we'll look at that later. It's not a billboard, chat. Because here, look at how they rotate. Look at how they rotate. This one, look at how it rotates. Where we look. We don't want that, chat. We want it to be based on the player position. Only the player position. So let's not use billboard. Let's not use. Let's go back to the wires. How are we going to rotate? Like, let's draw something else. Let me think about it, chat. We want, okay, let's create a model. Load model from mesh, and here generate mesh cube. Let's generate a mesh cube. And let's do this only once here. Let's do it once here. We generate a cube. Do we give it dimensions? A width, height. So width we can do the same. Height we can do 16. And length 0. So we have this. We need to change the model sprite. We need to change the model sprite. No, Detective Jones, the player was only F5. Change the F5. To have different perspectives. Let's update the model materials. We want how to set the model textures. Here, let's do Raylib model. Models. No, not this one. Generate mesh. Generate mesh. Yeah, this thing. How do we change the texture? We go to the, yeah, here. Materials, materials, map, diffuse texture. So we do model, materials, map, diffuse texture equals world get texture rain. We get the rain texture. Yeah, we'll animate it, but one thing at a time, man. One thing at a time. And here we draw model. Draw model. We draw, yeah, model with position. With position. And scale and tint. Like that. Okay. Now we should have better mesh. Without rotations, but now we can actually rotate it. It's not, it doesn't have, it doesn't discard pixels. It doesn't discard pixels, but it's fine. Let's just do the rotations. Let's just do the rotations. It's fine, chat. Let's do the rotations, chat. Let's do the rotations. Yeah, making crane, chat. Let's make them rotated towards the spawn point. Towards the spawn point. Let's do that, chat. How wide are they? Are they 1 by 1? Are they 1 by 1? Probably. Probably. I'm not sure how to test. Yeah, we can test this one actually, maybe. Or this one. Ah, it's fine. We can do, we can test, because I'm doing the width to be 0.9. I'm not doing a whole block. I will test. We're doing crane. We're doing crane, chat. Rain. Let's rotate them. Let's rotate them. So draw model. Here, draw this. Just need to copy this part. Chat is getting annoyed. Let's draw it like this. Float scale equals 1. Rotation axis is on the Y. And we need to use this. We need to use this. And we need this position. This position here, this is white. Like that. So now we can rotate them. Now we can rotate them. But we need to decide what angle each one should be. What angle each mesh should be. How to calculate that, chat? I'm not good at math. How to calculate that? How to make it, like this one is rotated perfectly, but this one needs to be rotated 90 degrees. How to calculate, here I need an angle. The rotation axis is the y-axis. Is the y-axis, but I need an angle. I need an angle, chat. So we have, here is the position that we need to rotate towards. And so let's say we have another position here. And how to get the, how much to rotate? You need to make all the quads rotating towards position. Yeah, how to do that? Minus current position and then normalize. Yeah, but that's just the vector. That's just the vector. Like you do on particles. No, particles, I just used draw billboard. Yeah, but let's look at it as a reference. Billboard. Let's use it as a reference. Because they probably do the same. They probably do the same. Yeah, matrix look at. They have a target, position, and an up. Perfect. So we have a matrix. And how are we going to use this matrix? How are we going to use this matrix? Where do they actually draw? Coordinates, vertex, points, these points. They manually calculate the positions. Yeah, matrix look at. We can do I'm not sure, chat. Because they do it differently. They like calculate the vertex positions themselves. They do it themselves. They don't calculate rotation angle. They don't calculate rotation angle. A quad transform, matrix transpose. Something like this. You sure, man? No, let's look at 1 second, man. 1 second. Let's look at draw model. And here, how do they use the rotation angle? They just they create a matrix here. They create a matrix here. And here for matrix rotation, we can do matrix look at instead of doing this, maybe, question mark. But let's look at how they use this function. Let's look at how they use this function from examples. I'm sure an example would have used this in a way that will help us. Here, they just give it a static angle for rotation. Draw model points. Oh, that's fine. What's this? This is just rotation. We could calculate the angle ourselves. We could do that. We could do that. Here we have two positions. What angle do we need? We want maybe this angle. No, not this angle. Not this angle. It's this direction. Okay, to calculate this direction and to see the current default rotation. Let's say default rotation is like this. So to calculate this angle. This angle. I think. I want, so if it's like rotated like this, I want it rotated like that. From this to that. Here it will be like this. 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 That's it, chat. It's very simple. And they're looking towards here. What options do we have? Yeah, we can do the calculation ourselves, but can't we use something else, chat? Can't we use something else? So you are suggesting like a function to use directly, but I don't want to use that, chat. I'll have it in mind. I'll have it in mind. I want to test my approach. If that doesn't work, I'll use your approach. If it doesn't work here, I'll have your approach in mind. I'll have your approach in mind. We could just draw, do this function, but with slight differences. Just change the rotation matrix, maybe. But let me think about it, chat. So default, this is 0. This is an angle of 0, let's say. Yeah, let me look in game. Let me look in game. Let me look in game. What's the default? What's the default? The default is looking towards the... So this is the z-axis. This is the z-axis. So they look towards the either the south or the north, something like that. So let's say this is the x, this is the z, this is x, this is z. So by default, this is 0. This is 0, this is 90, this is 45, this is 180 or like 0 again, maybe. Yeah, so that's it, chat. And how do we go here from 0 to 45? We only have positions. Yeah, we only have positions. This position, this position. This is 0. A10, calculate angle between positions. The angles are not in increment 45. Yeah, what's this? Angle between 2 points. Is it between 2 points? Is it between 2 points? So it's doing it like this, between 2 points, maybe. Like here, let's say here is the 0. Here is 0, is doing this. And here an angle. Is doing that. That's different, chat. That's different. That's different. We could calculate here a vector towards this direction. And I have no idea, chat. Okay, I have some clue. Now the center of the angle is on the point. Center of the angle? What do you mean? No, chat. Don't worry about it. We can do the draw billboard stuff. Here, we can use the matrix. We can use the matrix, chat. Let's just use this matrix. Look at matrix. Let's just do that, chat. No. Yeah. Let's do that, chat. Maybe. Yeah, but... let me think. Bro, I hate math. I hate math, chat. I hate math. Let me think about it, chat. How are you going to calculate the angle? And here, what's the difference? What's the difference here, chat? Look at. Yeah, but I don't. Isn't it expensive? Matrix look at. Is it like to calculate matrix? Okay, it's fine. Okay, let's do matrix. I was worrying it's maybe expensive to do that. No, I was thinking it's expensive, but let's do it. Let's do it. Okay, let's first try this approach from chat. Let's just try this approach. But what is the first position? What's the other position? We'll ignore y. Okay, just x and z. We have this position. We have this position and this position. And here we need two positions. If we give these positions, it will give an angle here. We don't want this. Subtract them and normalize the directions, then put it into a tan. If I subtract them, it will give a direction here. Where is it? Here. If I subtract them, it will give direction like this. So just give a direction. And here it will be like this. What? How is this 0 and this 90 degrees angle? Put that direction, which will give you radians, which you convert. Yeah, but a tan needs two positions, right, chat? Oh no, chat. No, I was thinking like to subtract this position from the normal instead, right? To use a tan with these two positions. But again, it will give... No, it will be always the same angle. No, that's stupid. That's stupid, chat. Yeah, I cannot do the a tan stuff. I'll do the matrix, chat. I'll do the matrix. And here we'll do the rain, position 2, player position. Subtract spawn point position from rain position. Yeah, but that gives a vector that points towards the spawn point. Oh no, chat, you're right. You're right, chat. Yeah. Let's remove this stuff. Let's remove them. Okay, chat. Yeah, it's simple. We do a vector towards the here, towards the like this, chat, like this. I think like we'll have default to be like this. We'll have a default arrow, and we'll have another arrow that points towards the rain, like this. And the angle between them is 0. But if it's pointing towards here, this angle is 90. That's it, chat. Okay, chat, that's it. This angle is 90. Yeah, it's simple, chat. It's simple. Yeah, it's simple. Yeah, it's simple. Okay, we figured it out, chat. Thank you, chat. We figured it out. By we, it's you. You guys figured. Okay. We want a difference. Vector 3 subtract. We want to subtract. I want to go from the spawn point towards the rain. That's how I want it. So from the rain position, I want the rain position. Let me think about it. Yeah, let's do rain position, and here the spawn point. A spawn point like this. And we don't need to normalize the chat, right? Because it's just the angle is the same whether we normalize it or not. We don't need to normalize it. It's the same. And let's have the vector 3 compare position to be the rain position spawn point, the spawn point plus 0, 0, and on the z 1, let's say 1 on the z. vector 3, vector 3, and we need float angle equals this calculation. Isn't there a function in Raylib for this? Raymath. They probably have tan. They probably have that. Or sinus, cosinus. They don't have it. Okay, do they have angle? Vector 2 angle. Calculate the angle between them. Okay, they have a function for this, chat. They have a function for this. Calculate angle relative to the origin. X is right, positive Y down. Does rain create splash effects? No. Check inside of it. Okay, we can check inside of it. Line angle. What's line? Defined by a two vectors line. Parameters needs to be normalized. Current implementation should be aligned with geo angle. Yeah, let's do vector triangle. Vector triangle between difference and compare position. And let's see what does it do. Oh, square root. Oh, why is it a square root, man? Why is it a square root? Why is it a square root? Chat, why do they do square root? Oh, it normalizes them. Okay, okay. Okay, we'll have here the angle. We'll have, let's see the result now. Let's see the result. Let's see the result. Yeah, it needs to return a float. Needs to return a float. Needs to return a float. They're not rotating. Chat, they're not rotating. We're giving it an angle. Sure. We have different pointing towards the rain position. And here, from spawn point, Z, then angle. Do we need to normalize them? Oh, it's in... No, it... Oh, if it's in radians, that's a problem. If it's in radians. Because here it expects to be in degrees. It expects in degrees. I can change it here. Radian to degree. I can change it, it's fine. Oh, so if it's radians, it's very small rotation. Oh, it's rotating, chat. Yo, it's rotating. Let's go in the center. How is it? It should rotate towards the rain. Towards the rain. Should be towards the rain. Chat. Oh, no. There is a one problem, chat. There is one problem. Here where they calculate the angle, they say, this is what they expect. They expect positive X to be right. Positive Y is down. Wait, positive Y is down. We need to change that. Angles appear clockwise, negative angles appear counterclockwise. Yeah, positive X is... Yeah, positive Y is down. We need to change that. Wait, Y? The Y, we can just set it to zeros, the same Y. We can just set it to be the same Y. I don't care about the y, right? We can do... No, chat, wait a minute, chat. I want to do something. Y, I want it to be the same one. Spawn. We have a mistake in the naming. It should be spawn point, not pont. But it's fine. I'm setting the Y to be the same. Setting the Y to be the same. Here was the issue. Okay, we can just do 8tan too. We can just do what they do, but differently. Here, we'll do our own calculation. Oh, they do a cross product. Bro, why do they do a cross product? This is a different vector. Why do they need a cross product for calculating the angle between them? And then a dot product. This is V1. V2. Oh, a dot... Bro! An angle, isn't it? An angle, a dot product. Like the dot product. Dot product. Like dot product is an angle between the two of them. It's an angle. Why not just use a dot product? Okay, we can do this, chat. We can do this. Here, float angle equals like this. And here we'll do... What was it, chat? We'll do... Where was it, chat? 8tan2 angle between vectors. What was it, chat? Yeah, this is it. Vector 1, vector 2, then vector 1, vector 2. Yeah, chat. We'll do it more simpler. Here we do... We'll just do vector. Let's name them vector 1, vector 2. Here we do vector 1. Oh, we just do the x and z. We just do the x and z. So here vector 1z minus vector 2z, and then we do vector 1x minus vector 2x. Like that. Like that, chat. And let's test it. It has rotations. But not proper rotations. These ones look kind of alright. And these ones kind of. But these ones are not. For some reason. Yeah, on the north and z, these ones should be 0 rotation. This should be 0 rotation. And it's rotating at like almost 45. That's wrong. That's wrong. Should I normalize them, chat? Should I normalize them? Oh, yeah, let's normalize them. Let's normalize them. Normalize them. Just to be sure, chat. Now, these ones are pretty good. These ones are not. they're at almost 90. We could have an offset for the angle, be like, I don't know, chat. I don't know, chat. I'm not sure. A flipped sign. In the vector 3 subtraction, maybe. But I normalize them. Think making. We have an alternative, chat. We can just use a matrix. Just like in... we can just use the draw billboard matrix. Let's just do that, chat. Let's just do that. It's fine. No. It was... what was it, chat? Yeah, here, matrix look at. Should probably the rain position, not the difference. Yeah, we can try it. If it doesn't work, we'll use matrix look at. We'll just use a matrix. So you're using the camera position and rain position. And somebody else in chat is just using the X and Z of something. Let me think about chat here. So instead of subtracting this to be just the rain position and this to be the rain spawn point. Let's test this. Yeah, we're using the rain position and the rain spawn point. And let's see how this is. This is pretty good, I think, but we need to flip them here. So 90 degrees. Let's do minus 90. This looks pretty promising. Let's do minus 90. Let's do minus 90. Now the other ones are flipped. Bro, we're pretty close, man. We're pretty close. So here to change this to be 2, this to be 1. Let's flip them. Should be the same result, I think. Should be the same. Yeah, it's the same result. Yeah, we just need these ones at the to be 90 degrees. These ones to be 90 degrees. These ones to be 90 degrees. So X and Z to Z and X. Here to be X. Sure. Why not? And this is fine like before. Let's test it. Like if this works, it's very promising because it should be performant. We don't do that many. Bro. Yo, chat, that was it, chat. Rain, chat, rain. Bro, that was some magic, man. Bro, that was magic. Rain, chat, rain. But it's not animated and we need to remove we need to discard the black color and we need to use the player position. Okay, let's now use the player position constantly. Let's use the player position. Yeah, now we'll make... I didn't make it move with the camera just so we could look at it from up. just to be sure everywhere it's all right. That's why I made it like that. That's why I made it like that, chat. Yeah, it looks all right, chat. It looks all right. This here is what they do in Minecraft. This is this, chat. We just looked at what Minecraft does and we replicated it. This is it. We replicated it. We just replicated it. Okay, chat. So now let's make it be the player position, the camera. Let's make it be the camera. Let's make it be the camera. So here, here this will be player. I want this to be player position, right? Player position. And yeah, look at this, chat. They change based on the player position. Look at how they open up. Look at how they open up. That's cool. But we need to update the rain positions. We need them to follow the player constantly. And to do it every no, Minecraft does. Bro, you're rage baiting gaming. You're rage baiting. We look back in the vote. You'll see. You'll see, man. You'll see. Just look back at the vote. Minecraft uses the position. I can promise you that. Minecraft uses the position. But what now, chat? What now? Now, okay, it's fine like this, chat. We don't need to make it move with the player. We'll just stay here so that we can prioritize more important stuff. Let's now change the sprite stuff. Let's make the sprite stuff. Yeah, here is the player. Here is the player in F5. This is it in F5, chat. Oh, I muted this guy, and now he made another account for the vibe code stuff. Bro, stop asking me for vibe coding, man. We're not vibe coding. Let's fix the sprite. For the sprite, we need a shader that discards the color if alpha is below 0.5, let's say. Let's see. So, yeah, we need a custom shader. We need a custom shader. We need a custom shader here for the model. For the model, materials, shader equal world get shader, the terrain one maybe, the terrain shader. Yo, chat! Chat! Wait. Wait a minute. No, it's chat. Yo. We need to make it fall down. We need to make it fall down, chat. Yeah, now just animate it. Just animate it. um How to animate it? We could change the sprite itself. But let's update the thumbnail. This is a good one. A good one. Let's update the thumbnail. Yeah, I updated the thumbnail. Where is chat? Here is chat. Who should I ban, chat? Who should I ban? Who's making trouble? Who's making trouble, chat? Who's making trouble? Yo, who's making trouble? Super wheat? Oh, this guy. Don't chat. Anybody else? Okay, chat. Let's animate this. How are we going to animate it? Chat. How are we going to animate it? How are we going to animate it? Yeah, we have 3D Steve, chat. Look at this, chat. We have 3D Steve. To move the UVs. Sussy Baka, man. Bro, what's that name? What? What's that name? Let me see about this. This is the sprite, chat. This is the sprite. This is the sprite. Oh. Yeah, how to scroll the UVs? Because the Raylib handles my model. Because Raylib handles the model stuff. Let's look at the... Yeah, where do I draw the rain? Where did I draw it? I'm drawing the rain... Where am I drawing it? One second, guys. We're drawing the rain here. No, not this draw billboard. We're not drawing billboard. We're drawing this, chat. We're drawing this. Here we have, what do we have? We have the model. We have the position, rotation axis, the angle, scale, and the tint, the color tint. And inside of here, these are just some matrices for rotation, scale, translation. We don't care about that. Here for the material color, and here draw mesh. We draw the mesh here. Oh, shader, bro, we can do a shader, chat. We can do a shader. Yeah, we can do a shader, chat. We can do a custom shader. 1 second, chat. Okay, let's do a shader, chat. Let's do a shader. Let's do a shader. We'll do a shader where it animates this. Most game use shader for particles. Each effect is its own shader. We're adding rain, chat. We're adding rain. Yeah, I thought sub mode was from the start of the stream. I didn't know, man. I didn't know. Yo, Raptor, bye, man. Thank you for the help. I thought sub mode was from the start. I didn't know that. I just found we didn't have sub mode once we got some troublemakers. How should the animation happen in the shader? How should animation happen in the shader? Let's see a custom shader. I have some shaders here. I have we need a fragment shader, I think, right? Let's look at the vertex shader, for example. A vertex shader, I want it to be GLSL so that we have coloring. Let's do here. Let's create new shaders. I want to create new shaders. New file, rain vertex, and new file, rain fragment. No, it's rain fragment, but GLSL. I want it to be GLSL. GLSL, like this. And I'll use a simple one. This one. So rain vertex and fragment. Fragment, like this. This is the fragment. And this is the vertex shader. Why doesn't it have the coloring, the syntax highlighting? Why don't we have syntax highlighting? GLSL. Yeah, this thing. Yeah, we have it enabled. Oh, frag vert. Okay. So here we do. I need to change the naming. Vert. And this. Fragment shader, like this. Okay, now it works. Perfect, chat. Perfect. So we want animation for the rain. We want animation. How are we going to do the animation? What do we use here? Let's right now we use them. Let's create the custom shader. Let's create the custom shader. Let's create a custom shader on a touch shader. Yeah, here. I'll have a rain shader. Rain. We will use rain vertex shader and rain fragment shader. And where did we draw the rain? On render. Where did we draw the rain? Yeah, here we want to use rain shader. Let's see if it still works. Okay, it still works, kind of. Yeah, it still works. Okay, so let's make it animated. So we have two options. One option is the vertex shader. What does it get as values? It gets vertex position and texture coordinates. We can change the texture coordinate maybe. Yeah, we could change the texture. There should be an example somewhere. Vertex, shader, pan, texture. There should be an example. This is just position. Oh, but we need to get the time as well. We need a uniform of how much time has passed so that we can animate it. Oh, but is the animation the same? This will make the animation the same. We will not have an offset. It will make the animation the same. That's a problem if we do it in the shader. It will make it the same. And if I look at the raindrops, yeah, when passing the UV value from the vertex, we can offset it. We can change it a bit. That's fine in the shader. But how can we make it different for all of the models to have an offset for all of them? How to make the animation okay, this is a future problem. We don't care about future problems. Let's focus on current problems. Let's animate it, chat. Here, we use texture coordinates here. And they should be what, chat? They should be between 0 and 1, maybe. Oh yeah, we can use the vertex ID as a random seed. Oh, yeah, we can. Yeah. Yeah. Here, how to. Okay, here, how to offset it. We need the current time, like. We need current time. Raylib. Shader animation. No, I wasn't doing lighting. I was not doing lighting. Do we have Raylib example for animating texture? Sprite animation. No, this is different. This is different. Let's give here a uniform in the vertex shader, uniform float time for the animation. I need the time for the animation, and let's give this uniform. Let's update this. But how should we update this? On update, I want to update the shader. Yeah, here. I want float time equals get time and set shader value get shader of the rain. The rain shader, I want to give it time. No, what's this? Oh, I need a location. I need a location. Get shader location. Bro, I need the shader again. Shader equals world get shader rain. And here shader here shader what's the location, what's the uniform name? Just time, right? Yeah, just time. And we give it the time variable, and we're using shader uniform float. We're using a float. Yeah. Okay, we're giving it the current time. We'll use the time for the changing the UV. Sure. And in the vertex here, how are we going to use the time to change the texture coordinate? chord, we just need the y-axis. We just need the y, or to offset all of them, I think. The 0 and the 1, right? The wait, it's a vector. What's this? What's this? It's a vector 2. So the y plus equals time. Let's just do that, chat. Let's just do that. Yo, chat. Rain is falling down. Chat. Rain is falling down. Yo. We are animating it in the shader. Vertex shader. We're animating it. Bro. W, chat. W. Yo. That's good, chat. That's good. That's good. That's good, chat. And here the rain stops. We need to make now the rain follow the player. We need to make it follow the player. We need to make it follow the player. And we need to offset the animation to make it a bit random because it's the same animation. Yeah, but this is good, chat. This is good. It's raining down. Yo, chat, we did a lot. Man, we did a lot. Yeah, that's cool. Yo. Yeah, okay, let's move the... Okay, let's move the rain. Let's move the rain. Let's move the rain. We can do it... Bro, it's the last stream. There'll be 7-day break, man. That it's fine if it's above 3 hours. It's fine. But you're like in the school when you're like asking the teacher, but there was homework, right? No, you haven't given us homework, teacher. You haven't given us homework. It's the same feeling. Okay, let's make the rain follow the player. Let's make it follow the player. Let's make it follow the player. Let's commit this. Rain animates. Let's commit this. Let's make it follow the player. The code that we execute when we press the right shift, we'll just do this code. We'll just do this code a bunch of times. We'll do it every frame, not every frame. We don't need to do it every frame. We don't need to do it every frame. Here, let's just have... let's just toggle rain. Let's have this key to toggle the rain. Let's just have it toggle rain. And here we'll do the rain. Here we'll do the rain. And let's have... I want to use sticks. I want to use stick, like to do it on the next stick. To not have to manually do some stuff. No, it's fine, it's fine, it's fine. I'll do here float. Last time updated rain. Last time updated rain. And rain position. And here on attach we do last time updated rain position equals get time. And on update here, if get time. Do we have current time? Float current time. If current time minus last time updated rain position, if it's greater or equal than 0.05, that's when we update it, not every frame. Last time updated rain position equals current time, like that. And so they should be updating. Bro, we shaders to do it in no, bro, it's the wrong approach. It's the wrong approach to do it in the shaders, because we do calculation to collide with the ground so that we can have these splash particles. We need the position of the terrain, chat. It's not that simple to change the position with the fragment shader. It's different, chat. It's different. It's different, chat. Because if we look at the mesh, where is the mesh? Here. No, not here. Here. If you look at this chat, look at how the mesh has an offset on the y-axis. Do you see that? It has an offset on the y-axis. This is the rain position. It's based on the terrain. It's based on the terrain. This is not from the shader. This is from code. And it's fine to do it. We're doing it like Minecraft does it, chat. They're doing this for a reason like that. We'll do it like Minecraft. So now, let's see if the rain follows the player after we handle the compilation error. Multiple definitions. Okay, where is it defined? Multiple definitions. What did I remove? Oh, I removed the wrong stuff. You could make it based on real life regional data, so if it's raining, it snows in game. If we make it regional, I'm not sure. Then it will rain for 50 Minecraft days. Here we don't need this, but where do we use it? We use it here. Get current time. What's the issue here? It was acting very weird. What's the issue here? What's happening right now, chat? Why is it so slow? Why is it so slow? It's like in an infinite loop. Let's pause it. Where does it pause? Oh, we don't have probably the positions. Yeah, oh, no. Here, if draw rain. Like this. Let's first enable the rain. Yeah, it's the rain started too early. Rain was starting too early. Okay, let's drop on the ground and enable rain. Okay. Oh, we need to... No. Rain spawn point. We need to change this. This needs to be player position. Player position. Needs to be the player position. Needs to be the player position. And what now? Now let's enable it. Now it should be following the player, chat. Now we are away from the initial spawn point. Now we have rain forever, chat. Have rain forever. It's following the player. And now let's do bunny hop like this, chat. Bro, this is so weird. It's following the player, chat. Following the player. Yeah, W. Nice, 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 nice. Nice. Now let's have an offset for the rain animation. Let's have an offset for the rain. Yo, this looks so cool, chat. Oh yeah, and the colors to make it darker. To make it darker, because when it rains, it's a bit darker. Yeah, chat. Yeah, we need to make it a bit random. Need to make it a bit random. How to make it? How to make the in the shader? How can we make some kind of an offset? No. In Minecraft, let's see how it is in Minecraft. You say it doesn't go straight down. Oh, wait a minute. They maybe have some changes in the alpha to not be so easy to notice. Bro, look at how cool they've made the rain. It's as if it's dripping. It's very cool how they've made it. And it's a lot darker. It's a lot darker. No, you cannot make uniform have different values. The uniform has the same value. It has the same value. Let's see in the shader, can't we have in the shader, a vertex shader here, can't we have based on like some shader magic? Vertex, GLSL, vertex, shader, ID, GL vertex ID, index. Okay, let's do vertex ID. No, that's wrong. That's wrong because we need to divide it by 4, something like that. Divide it by 4. Because it's a quad and it has like, I think maybe 4 vertices. Here we can do int ID equals vertex ID divided by 4 maybe. Can we do that? And here time plus ID for some kind of an offset. Is it different, chat? I feel like the animation is the same. Is it the same? You need to draw a vector from sky. It has offset. Oh, you're saying it has an offset? It's difficult to tell, chat. It's difficult to tell. But look at this, chat. Look at this. It's not raining here. Chat, look at this. It's not raining under here. It's not raining here, chat. Look at this, chat. It's not raining here. This is cool, chat. Chat, this is cool. And here it's not raining. Bro, chat! It's raining outside! Chat! It's raining outside! It's raining outside. Yo! That's cool! And what if we start going underground? What if we go underground? Look at this chat, train stops. Because look at this chat, train. It's just here. This is cool. Bro. Bro. That's awesome. It's still raining outside. Yo, that's awesome, man. That's awesome. That's a nice bonus, chat. That's a good bonus. Do we have an offset? I'm still not sure. It doesn't matter. Let's make the sky darker when it rains. Let's make it because it's too bright outside. Refraction. I don't know what that is. Okay, let's make it darker. I don't know if we have an offset. I'm not sure. We can slow it down here. Let's divide it by, let's multiply by 0.05. Let's animate it more slowly. Okay, the chat, does it have an offset, chat? I think. Can we not randomly? Oh, it's not random. It's not random. Yeah, it's not random. It's not random. How can we have GLSL shader random? Randomness. I want randomness. Or maybe to use a texture. To use a texture. How can I get a random value, chat? Was this chat? Was this? Like we can use like some kind of a texture noise. We could use some kind of a texture noise, but can't we use something simpler? Random number between 0 and 1. This is float, but this gets a vector 2. Do we need a vector 2? Yeah, what would... I don't want to input anything. Yeah, I look at the stuff you write and I don't understand it. I don't want to use stuff I have no idea about. Yeah, I don't know, chat. I don't know. It's fine. To use as an input. Oh, yeah, we can do that, chat. We can do that. We can do that. Here, let's take this. And here have Yeah, we just have an ID here. We have an ID. Yeah, I need two I can just use the X value. I can just use the X value. Here. Here I can do random ID 0 of like vec2 ID and 0. Can I do that? Oh, maybe this needs to be above. Like that. Can I do that, chat? Let's test it out. Is it random? Random offset? Is it random offset, chat? Some of them are quite aligned. Yes, some of them are quite aligned. Also to multiply it, to change it, to increase it, to increase the value. Let's this value, let's increase it here. Let's double it, just to be sure. If it's because if it's offset between 0 and 1, maybe it's too little of an offset. Maybe it's too little of an offset. Oh, now it's pretty. It's fine, Chad. It's fine. It's fine. It's fine. We have bigger priority because we don't have that much time. We have bigger priority. Let's make the sky darker and the fog darker. Let's change those stuff. Minecraft rain color. Rain. What color do they use? They use this color. Oh, it's a gray color. No, we're not randomizing rotations. Okay, let's create a color. Let's create a color here. Rain sky color. And here we'll do 103, 103, 103, like this. And where do we use them? Where do we use them? Here for the biomes. Get sky color. Get sky color. Where is this? This is in game layer. So here, if draw rain, return rain sky color, like this. Done. Let's test it. Let's test it. I should have some kind of transparency in the clouds. We have fog, it's just not dense. Okay, let's have the colors be a bit transparent. Okay, let's change the clouds. Yeah, cloud, we have a fragment shader for the cloud. Here we just make it absolutely white. Let's have it be 0.f on the alpha. On the alpha. Is it? It doesn't look like it. Texel color, final color. And it's a mix between fog color, final color. Fog color, it's fine. Texel color. Where am I drawing them? Where am I drawing the clouds? Where am I drawing them? Clouds. When am I drawing them? Cloud texture, cloud model. Where do I use here? Draw model, cloud model. Where is this? In the beginning. We need here color blending. We need color blending. We need color blending. So here, after we enable color blend. After we enable color blend. Yo, now they're a bit transparent. And let's make them more transparent. Make them more. Clouds. Let's make them more transparent. To darken them. Yo, they're even... Bro, this looks better. Why didn't I do this before? How is it in game? How is it in Minecraft? In Minecraft? I kinda like it. We can bring down the alpha even more. We can bring it down to 4 or 3 even. Let's do 3. Alpha of 3. Yo! And this is when it rains. It's alright, man. It's alright. It's good enough, chat. I'll think about it some other time. It's fine, chat. It's fine. Fine. Bro. Let's update the thumbnail. It's fine, chat. Let me update the thumbnail. We implemented 2 features, chat. Where is chat? Where is chat? Okay, chat. Chat, it's the perfect time for the rain because of the news. This is the last stream, chat. It's the perfect time for rain, chat. It's the perfect time for rain. This is last stream, chat. We have 7 days break, chat. 7 days break, chat. 7 days break. But I'll be working on the videos, chat. I'll be working on the videos. I'll be doing but hopefully my laptop can handle rendering videos. Hopefully my laptop can handle rendering videos. Because I'll not have access to this computer, I'll just have my slow laptop, which cannot stream. So I'll be trying to do the videos. Because the videos are 1 month behind, I'll try to catch up with the video editing. And after 7 days, we'll stream Minecraft development. If I manage to stream something else, I'll probably do it. question and answers, going through projects in Discord, something my slow laptop can handle. Something the slow laptop can handle, but it cannot handle this for sure because it's very bad laptop. If it can handle something simple like going through the projects or organizing a game jam, I don't know, we'll think about it. Or doing question and answer in Discord call. There are many ideas, chat, many ideas. But let me summarize what happened. So in this stream, in the start of the stream, chat voted to have 3D Steve, and we added 3D Steve. Which is just a toggle with the F5. It's just a toggle of the F5, and it doesn't animate, but at least it has the proper collisions. It has proper collisions, and it rotates with the camera. And the head doesn't follow the camera, but it's fine. It's fine, chat. It's not that big of a deal, and we can look in front of Steve as well. And we can bring back in first person. The other thing we added is the rain. We added weather. And currently it's just when I press shift. Just when I press a key on the keyboard, it starts raining. And it changes the clouds to be this gray color. And the cool part is, chat, the rain stops here. When you're undercover, the rain stops, just like in Minecraft, chat. That's very cool. And look at this, outside of the window, it actually rains. This is my favorite part, chat. I really like this, chat. How we get this feature. This is my favorite part of the rain. So we managed to implement... Oh, let's break... Yeah, you're right, chat. Let's break a hole. It rains here inside the house. It rains inside of the house, chat. Yo, that's cool, chat. That's cool. And rain actually has particles when splash effects. It has a splash effect in Minecraft, but it's fine. Here, it has splash effect in Minecraft. We don't have it. We had the limit of 1 hour. We went past the 1 hour limit, so we couldn't manage to fully implement it. But it's good enough progress, and this is how they do it in Minecraft with this complicated mesh. We managed to implement the complicated mesh system, and each of this has they rotate to where the player is, and they have the rain sprite. They have this rain sprite. That's how we do it, chat. And this is it, chat. This is it. So thank you for watching, chat. And thank you for watching, chat. And after 7 days, we'll have another stream. And during these 7 days, I'll try to render more videos if my laptop can handle it. And whatever the laptop handles, that's what I'll do. Hopefully, there's something I can do on the laptop. So we'll be back in 7 days, chat, if I don't think of something else to do. Yeah, thank you for watching, chat. We had a lot of progress today. Bye, chat. See you in 7 days. Bro, where is my OBS?